Okay, so now let's take a look at exercise 7 of section 2.7. We still want to find the composition of two functions, f of x and g of x, and we still want to determine whether or not they are inverses of each other. So let's take a look at how we do this. Again, as in 2.7.5 exercise, we're going to take g, which in this case is 3 over x plus 4, and we're going to make that the input to f. Now notice what f does. Whatever you put into x, you're going to subtract 4 from that and make that the denominator of the fraction that has 3 as numerator. But we're putting in 3 over x plus 4. So let's simplify this denominator. So the denominator is 3 over x plus 4 minus 4. But obviously, if we subtract 4 from 4, we simply get 0. So now our denominator simplifies to simply 3 over x. So 3 over x is the same as 3 divided by 3 over x. That's another way. Remember, a fraction bar means divided by. So we're replacing this main fraction bar with the division symbol. 3 divided by x, by 3 over x, is the same as 3 times x over 3, which is the same as 3 over 1 times x over 3. And so notice I can divide this 3 in the denominator into this 3 in the numerator, and I get a 1. So there's a 1 here. 1 times x is simply x, and I also can think of myself as having a 1 here, and 1 times 1 is 1. X over 1 is simply x. So we see that f of g of x is x. All we can conclude at this point is that f of x and g of x could be inverses. And you could say they could be inverses of each other, but it's sufficient to say they could be inverses. So we won't know whether they're inverses or not until we determine what g of f of x is. But all we know is they could possibly be inverses. So now we want to calculate g of f of x. So we want to put the function f of x into g. And remember, f of x was 3 over x minus 4. Now g takes whatever you put into it and divides it into 3. So we're going to divide what we're putting in into 3. And what I'm going to do, just to make sure this is clear, I'm going to make this red. So f is 3 over x minus 4. So that is the denominator of 3 over x minus 4. And one of the things we do to make this clear is to make sure our main fraction bar is longer than any minor fraction bars. So G divides what you put into it into 3 and then adds 4 to that division. So we have to add 4 to this. Now remember, this complex rational expression is the same as 3 divided by 3 over x minus 4. So we're rewriting that. And we still have to add 4 to that. Now, we know that whenever we divide fractions, we can always change it to a multiplication as long as we invert what we are dividing by. So 3 divided by 3 over x minus 4 is 3 times x minus 4 over 3. Okay, so notice that that's a rule of fractional division or division of rational expressions. So this 3 in the denominator divides into this 3, which is technically in the numerator, because we could think of this as 3 over 1. And so that actually gives me merely an x minus 4. So that results in x minus 4, this multiplication, and I still have to add 4 to whatever that product was. And notice how this results in x. So we have x minus 4 plus 4 equals x. So we found out that g of f of x is x. Earlier, we determined that f of g of x is x. Since these two things are true, f of x and g of x are inverses. And you could also say this same idea as saying they're inverses of each other. But it's actually sufficient to say that they're inverses.